Hello. This video we continue our chapter 2, the last two sections, 2.6 and 2.7. 2.6 we talk about the skill needs of the data distribution and the mean, median, and mode. What their relation among the three here. So check the first graph. You can see on the left hand side, it's a histogram, displays a symmetrical distribution of the data. And we have data number 4, number 5, only once, right? Number 6, we have 1, 2, 3, 3 times. That's exactly our histogram displayed here, 3 times. Then 7, 1, 2, 3, 4, 5, 6 times. And that's exactly 6 times here. So let's write down. Yes, we can see 1 time, 1 time. And if we have 3 times, this one we have 6 times of the 7, right? 2, 3, 4, 5, 6. 8, we have 3 times. And 9, only once. Number 10, data 10, only once. Okay? So you can compare left hand side, right hand side. They are symmetrical, right? When they are symmetrical, you will find out our mean, which is 7, is the same position of the median 7. It's same as the position of the mode. Mode is the most frequent data occurred, which is 7, same thing. Now, look at the graph on the right-hand side. It's still histogram for the data from 4 to 8 only. And you should notice, number 4, data 4, only once. And data 5, only once. Data 6, we have 3 times. Data 7, we have 1, 2, 3, 4, 4 times. 4. And data 8, we only have once, right? And let's look at our graph. Different frequency on the left-hand side of the highest rectangular bar, where you see the 7 here. Left-hand side, we have 1, 2, 3 bars, and dropping down to the tail side, going downward. Right-hand side, you can see only one rectangular bar, so the graph will go this way, ending with the number 8. So when the left-hand side of this highest bar here is, we call the tail, right? The left-hand side, we got a longer tail than the right-hand side. So this we call the graph is not symmetrical and it's skewed to the left, right? And we have one more type of the graph that we call skewed to the right. Should be the opposite way, right? That means right-hand side will be the longer tail than the left-hand side. Okay, while you are doing the homework, you will discover that. Okay, so let's move on to. Hello, let's continue to section 2.7, measures of the spread. We are to study standard deviation, a number that measures how far data values are from their mean. So we need to find the difference between each data with the mean. Then take the difference, go to the square power, add them up. Then we divide by n minus 1. If the data is a sample from a population. Sample data, we write as small x here. Small x for sample standard deviation. And the denominator, we need to take n minus 1, degree of freedom, because we are dealing with a sample, okay? Same thing when we apply to the grouped data. If a frequency table is involved, we need to take the class midpoint of each data to find out how far away from each data here, and their difference need to multiply with the frequency and go to the square power. Take their sum, divide by n minus 1 again. If the data is the whole population from population, so population, our denominator is all the numbers in that population. So we use capital N to make it different from the sample. So I hope you pay attention to this. When you deal with the sample data, the denominator should be n minus 1. The population, we just divide by total number in the population, okay? And left-hand side is the formula, is for a set of the same population data. And look at the mean, we use the mu, right? This notation is for population mean. The concept still the same. Find the difference of each data, how far away from the mean. Then take a difference, go to the square power, then add them up, divide by total number of the population. When we deal with the frequency table, the difference of each data with the mean, we need to multiply its corresponding frequency, then add them up and divide by this total number of the population. Okay? So I know if you work with the formulas, that's a lot of work. If your data set are only 5 to 10 data, still okay to work with the formula here. But if your data more than 10 data, 20, 30s or more, to do by formula, by hand, is consuming of the time. I would like you move on to learn how to use technology to do it. Okay, it's quick, faster, and with accuracy. Okay, so you can use a TI-83 or 84. If you could get the 84 is better because 84 got more function than the 83. Or you can use GeoGebra Classic. Just download from the Google, and it's free. Download to your computer, laptop. When you need it, you can use that free computer software. Okay. So to calculate the sample mean and standard deviation for the data below, this is example 8. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 data here. So I will suggest you use that technology to do, okay? To use the TID4, there's instructions in the textbook there, okay, very clearly. And we also have video prepared for you, posted at the discussions, how to use TI-84 to compute sample standard deviation. And for the GeoGebra, number 1, download GeoGebra Classic from Google. Number 2, enter data to the spreadsheets. The good things, if you have large data set, you can just highlight the data and select one variable analysis. Then click on the sum of the x, this symbol, which will show us all the statistics. Okay, and the solution, we should get x bar equals 73.5 and sample standard deviation equals 13.01. Give it a try. If you cannot come out of this same solution here, post your questions at the discussions, okay? And we will go over, discuss together.